welcome to EMS News. I am Kayla Sussing. Today in the news, the world is facing a crisis. Global temperatures are rising and alternative transportation and fuels are necessary. Our field team has found options for you to help reduce your impact on this travesty. First, we have Benjamin Satter.
One possible technology is the fuel cell. There are various different types of fuel cells that use different types of fuel. However, hydrogen is used most often in vehicles. But how do these fuel cells work?
A hydrogen fuel cell is made of an anode, a cathode, and an electrolyte membrane in between. Hydrogen is directed towards the anode, where it is split into hydrogen ions and electrons. The membrane allows only the hydrogen ions to pass through towards the cathode. However, the electrons must pass through an external circuit to reach the cathode. This movement of electrons is called electricity. At the cathode, the oxygen and hydrogen ions combine with electrons to form water. The electricity produced will be used to power the wheels.
This is what a real fuel cell looks like, and this is the tank that holds the hydrogen. But how does this compare to gas? One of the largest factors
is price. Currently, fuel cells cost about 10 times as much as an internal combustion engine. Similar to an internal combustion engine, there are subsystems needed along with the fuel cell, such as cooling and humidification. This is largely due to the need for oxygen at the cathode. Most of the time, however, oxygen has to be pumped in or blown in with a fan or compressor to be ready fast enough for the fuel cell to be practical. This uses energy and decreases the efficiency of the cell by about 10 to 15%.
However, a fuel cell has various positive attributes as well. It is about 50 to 70% efficient. This means while the energy cost may be high to obtain the fuel that is used extremely efficiently, and you get more usable energy from it with the current technology. At current prices, if hydrogen could be delivered to your car at the same price it is industrially, it would be equivalent to about $1 for a gallon of gasoline. If research and development can cut the price of the fuel cell and make obtaining hydrogen more efficient, a fuel cell is one of the most ecologically friendly technologies available. One possible way of obtaining hydrogen is using electricity to split the molecules in water into hydrogen and oxygen. If this is done with renewable energy, it is certainly for the ecologically minded. Back to you, Kayla.
Wow, what a fascinating alternative. On the other hand, electricity has powered our homes, industry, and many other aspects of our lives. But can it power our vehicles as well? Let's ask Evelyn Bateman to find out.
Electric cars are run by electric motors powered by rechargeable batteries. While the vehicles themselves do not emit greenhouse gases, electricity generation from fossil fuels such as coal and oil do produce carbons. That is why it is particularly important for electricity to be produced from renewable sources such as solar, wind, and hydropower. We're here at the Larson Transportation Institute, and this is an example of an all-electric vehicle.
Electric cars are quieter and operate more smoothly than their gasoline counterparts. Because of fewer moving parts, electric cars require less maintenance. That means no oil changes and no engine tune-ups. Electric cars are also more efficient than gasoline-powered vehicles. Around 60% of the electricity stored in the battery is used by electric cars versus about 20% fuel in a gasoline car. This is in part the result of regenerative braking technology. Regenerative braking systems conserve some of the energy required to brake and use it to recharge the battery. Unlike typical braking systems which release energy in the form of heat, regenerative braking helps to prolong the charge of the battery.
There are several types of batteries used in electric cars, each of which need to be changed every few years. The lead-acid battery is the most commonly used and also the least expensive.
Lithium-ion batteries offer the best vehicle performance. Though they are presently the most expensive type of battery, engineers are working to manufacture lithium-ion batteries at affordable prices. There are two primary means for charging electric vehicles: conduction and induction. Conduction requires the flow of electricity through metal-to-metal contact.
Induction involves the creation of a magnetic field to charge car batteries. This technology is the safer, preferred method for charging, but its high price makes it less economical. Back to you, Kayla.
How electrifying! Most of our considered gas-powered, but what if they run on natural gas? Is there a difference? Dr. Effluvium is here with us to discuss. I'm here with Dr. Effluvium, an expert in the field of natural gas as a fuel. Hello, Doctor.
Hello, Kayla. It's great to be here. Thank you for having me.
Before we really get into the beef of things, I've always wondered, do beans really give you gas? And if so, can that help to fuel our economy?
No. You're thinking of a different kind of natural gas. The kind I'm an expert on is a mixture of combustible hydrocarbons found in reserves buried deep beneath the Earth's surface.
Well, that sounds pretty similar to coal and petroleum. And isn't the burning of these two fuels harming our environment?
That's a great question. It is true that the formation of natural gas is very similar to oil and even coal, and these similarities are the very reason the substances are called fossil fuels. See, fossil fuels are formed from highly compressed and heated organic matter. There are other less common formations of natural gas from organic matter, but it is mainly formed deep in the earth where temperatures are high and the pressure from mud and sediment weigh down heavily on the organic molecules, breaking carbon bonds. See, eventually hydrocarbons are formed, and the deeper this decomposition occurs, the purer the gas becomes, and this is essentially the difference between natural gas and other fossil fuels. Coal and oil are formed closer to the Earth's surface and therefore contain a greater mix of compounds, whereas natural gas, in its purest form, usually consists of only methane or CH4.
But what is so special about a pure gas? And if it's so deep under the ground, how do we access it?
Well, the answer to the first part of your question is precisely the reason natural gas is so enticing when we consider the environment and global warming. See, the combustion of methane, which provides usable power, only releases 1 mole of carbon dioxide and water per 1 mole of methane into the atmosphere. On the other hand, the more complex compounds of oil and petroleum release greater amounts of carbon dioxide along with other greenhouse gases such as nitrous oxide. However, the power output of natural gas is about 40% as efficient as propane, providing a little over 1,000 BTU per cubic foot of gas, whereas propane produces 2,500 BTU per cubic foot in its gaseous form. Now, in answer to your second question, even though natural gas is formed closer to the Earth's core, because it is less dense than crude oil and coal, it rises to the surface, and some is trapped in sedimentary rock formations that soak up the gas. Above the porous rock are layers of impermeable rock that contain the natural gas. And we can think of these reservoirs of natural gas, we can access them rather, by drilling through the impermeable rock. And because the gas is at a much higher pressure than the air on the surface, the fuel naturally wants to escape.
Fascinating. It's almost like taking blood from the earth. But what happens when you empty one of these reservoirs? I can't imagine they always fill back up.
A good question. You are right. These reservoirs and these reserves of natural gas are not endless because there is not an unlimited amount of usable natural gas on Earth. This is the reason why natural gas, along with other fossil fuels, are called non-renewable sources of energy. The decomposition of organic matter into hydrocarbon compounds takes thousands and thousands of years, and the amount of fossil fuel we consume vastly outweighs the rate at which these fossil fuels are formed.
Well, do we know how much natural gas we have left?
Predictions about the limit of our natural gas supply have actually increased in quantity lately with the discovery of shale deposits. Now, estimates from the Energy Information Administration and from the Potential Gas Committee predict about 100 years more of natural gas supply if we maintain our current usage rates.
100 years is a long time. If natural gas is so much safer for our environment, why don't we develop it and use it for the next couple of decades until we have a better alternative?
Well, it is debatable how safe natural gas really is for the environment. Although natural gas is safer for the environment when burned, accessing the resource, especially when dealing with shale, can be quite detrimental. Extraction of natural gas from shale, called fracking, uses a different, cheaper method than drilling. See, instead, water mixed with chemicals and sand at very high pressures are pumped into deep wells, and the high pressure cracks the shale, creating fissures that allow the gas to seep into the well. However, leaks can occur, resulting in the contamination of an area's water supply, and chemical water can even leak into streams and rivers, ruining ecosystems and further weakening the water supply.
That doesn't sound good.
No, it is not. Natural gas is certainly a useful and convenient source of fuel, but it cannot solve the world's energy problems alone.
Well, that seems to be a trend through all the fuels that we've explored today. But it was great to talk to you, Doctor.
And thank you again for having me. It was an honor.
There you have it, another course on another source. Natural gas is a viable fuel for our world, but not perhaps the ultimate solution. Now back to the studio. For the final portion of this segment, we're going to connect to Dr. Knoll to elaborate on another form of alternative fuels, biofuels. Good evening, Doctor. We're so glad to have you on the show today.
Oh, hello, Kayla. So grateful to be here as well.
I understand you have some information on biofuels for us?
Yes, of course. Well, to begin, biofuel is a fuel made from living material. Two examples I want to expand on here today are ethanol and biodiesel.
Ethanol. That sounds familiar.
Yes, that's because a large amount of our unleaded gas is mixed with ethanol. Most likely, you've seen E10 gas composed of 10% ethanol. Some cars called flexible fuel vehicles have modified to use gas that is up to 85% ethanol, E85. Although E85 contains 75,600 BTU, while gasoline contains about 115,000 BTU. This difference means that it takes more ethanol to muster the same amount of energy.
But what is ethanol, Doctor?
Well, ethanol is created through a process of fermentation, distillation, and dehydration of starch found in crops such as sugarcane, potatoes, corn, and other biomasses. As of 2008, we produced about 90% of our ethanol from corn and 10% from wheat and sorghum.
Interesting. Do continue.
Well, not all of corn is used to produce ethanol, only the kernels. The leftover material is called distiller's grain and is fed to cattle, pigs, and other livestock.
Well, at least the livestock is fed.
Hey now, there are really many pros and cons of this fuel. On a positive note, ethanol can reduce our dependence on foreign oil and produce less life cycle greenhouse gas emissions. Although the percent of GHG emissions from corn is only 21% less than petroleum, and other resources like switchgrass and sugarcane produce drastically less. It should also be noted that the fertilizers used are creating runoff and dead zones in many areas. As you also said, we eat corn. 27.3% of our corn crop in 2011 was devoted to the creation of fuel.
How does this happen, Doctor? Food for fuel.
Well, the US has a mandate to produce a certain amount of ethanol each year in different states, driving up the demand for ethanol. This summer we saw corn prices rise 60% after a drought in the Midwest, causing the mandate to earn quite a lot of attention.
I'd say so. It seems that even though ethanol has positive attributes, there are also many downsides.
As there are with all things in life. The subsidy that totaled $6 billion for corn last year, ended as of January 1st this year, but it was successful in getting the industry on its feet. The subsidy for ethanol made from non-food is still in place, and we can expect an increase in ethanol made from switchgrass, wood, chips, etc. All in all, ethanol has earned a place in the US economy, and good or bad, it is sticking around.
Yes, I'm interested to see how the general feeling around the production of ethanol sways in the next few years, as it seems to have taken a negative turn.
We can only wait and see.
Of course. I would like to move on to biodiesel now, though, Doctor. I understand this fuel can be made from soybeans and other foods, but also waste vegetable oil?
You've hit the nail on the head on that one, Kayla. Biodiesel is produced from vegetable oils and animal fats through transesterification. An alcohol, like methanol, and a catalyst, such as sodium hydroxide, are added to the oils to make biodiesel and glycerin. After washing and drying the dirty biodiesel, you have a useful fuel and byproduct.
What are the upsides to using biodiesel?
Well, biodiesel is a great lubricant that can increase engine life and cleanliness. It also burns much cleaner than diesel. From soybean oil, there is 57% less GHG emissions, and when made from waste vegetable oil, 86% less. What's really great is that biodiesel contains 3.2 times the amount of energy required to produce it, and it's biodegradable. It's also much safer than petroleum because of its flash point, or when flammable vapors are produced to be ignited, it's higher by over 100 degrees Celsius.
Wow, that sounds great, Doctor. You're also making treasure out of trash.
Kayla, that is true. Using waste vegetable oil takes it out of landfills, and the glycerin produced can be used to make soaps and makeup.
Then what would you say are the negative aspects of this fuel?
Biodiesel, it gels at low temperatures, and the B100 runs with 10% less power than petroleum diesel. B5 is approved in most vehicles and B20 in some, but cars must be approved to run higher level blends. You also have to be careful that there are no rubber fuel lines, since the fuel is corrosive to rubber.
Well, all in all, both of these fuels seem like good alternatives to petroleum. I'm sure the industry for biofuels will continue to develop, and we'll see an increase in its production.
Well, the 2007 Energy Security and Independence Act calls for 36 billion gallons of biofuel to be produced yearly by 2022. So, we can surely expect an increase in production to meet these demands.
Well, thank you so much for talking with us today, Doctor.
But of course, Kayla, great to be on the show.
Alone, none of these technologies can solve our global crisis, but in conjunction with one another, they can create change. Tune in next time for our special live viewing of the nuclear-powered debate. Good night.